Today at the shed, we find out what happens when you just don't listen to your mum. What's this mad dog doing? Yeah, I'm reusing brake line as a clutch line. So this was from a Suzuki Swift that we had, and it's pretty much the perfect length for a clutch line. So I'm just going to straighten it out and yeah, put my own bends in it and just reuse it, rework it. It's all steel. There's no reason why you should just throw it away. Good enough. We get this piece. We can lightly conform it. If we want to do a large radius, just use it like that. And then we can, we can go around corners and things like that. Like really neat. So I don't actually want to do that. So I'll just make this really awkward for myself and twist it. So from start to finish, we got a KE70 clutch master cylinder, had that laying around. Brackets made out of patio tube. Heim joint there is left over from the shifter. Pedal was existing. We've got the line is 2011 Suzuki Swift. Got some of these little P brackets. They're from an old Hilux diff. And there's another P bracket there. Goes through. There's a union down there. That's from a Swift. There's another little brake line. It's off my old Starlet. Comes up there. Up to there. That standoff is from the Camry. The holding clip is off the MR2, and this is from a rear-wheel drive Corolla. And there we have a free functioning clutch line system. All that's reused. Someone would have thrown all of that in the garbage. There's no reason to throw everything away. You can reuse and recycle and repair. Alright, so this fuel system's a non-return system standard. Need to make some modifications to the rails. Basically, all I did was tap them to NPT and then out to push lock, and then straight into the fuel regulator. So we got both sides coming in, and then that'll come down. And then the fuel line will come down here and around. But the next challenge is going to be making this work. So, because of the ECU we're using, it needs this crank angle sensor. Now, what I have to do is adapt this to basically sit on here. what that's going to entail is welding a plate onto there and then putting some studs for these to go on, and then I've got to obviously make it drive. Now this has a offset key inside it. If I can get the focus. And inside there is the offset key. And basically I'm gonna have to adapt that to drive that. So what I'm going to do is I've got the bolt from the end of the camshaft that holds the cam gear on. I've had this machined out, and this is the drive that's been ejected from the standard camshaft. So I just cut the back of the camshaft off till it revealed the edge of this, and then knocked it, push this pin out. So that'll drive the crank angle sensor. So the idea is this is a press fit. So what we're going to do is do some white man magic, and we're going to warm this one up, and this should drop straight in. And there we have it. And this is what it should end up like. A Nissan Cass on a 1MZ. Alright, so I've got the crank angle sensor all hooked up here. I'm leaving it so it'll rotate 360 degrees at this point because yeah, I don't know how entirely accurate I was. Try to be as accurate as possible, but you know, it's easy. I can just put it to where I need it and then tap the holes, and that's it. It's all good. So I've got the wiring hooked up, I've got a lot of stuff verified, so now everything's sort of plugged in, and I'm just going to run through the steps of commissioning the ECU. So when we're coming to commission the ECU, one of the things I always like to do is just have a battery charger. You're probably going to be cranking this thing for quite a while. Alright, so all of our stuff works. We got power. There's a like little switchboard. Everything's confirmed to work. Go over to the ECU. ECU's lit up. And we'll come over here to our ECU software. And we'll go connect. So obviously it's like connected. We got the basic things like water temp's definitely working. All this motor really needs is TPS, crank signal, water temp, and bam. So if I crank, see that we've got consistent movement. Right. Volt's working, so ECU is sort of functioning basically. So the next thing we have to do is set the timing. So on the Microtech, we go into the setup, and we go to all the way here, TDC ref, and then if you're on a laptop, you press M to put it in program mode, and we will use this setting here, which is basically that's the timing offset, and we'll configure this crank angle sensor to TDC on the motor. So when you're doing timing, commissioning a motor, I like to have a separate battery hooked up for the timing light, and I like to use my digital timing light. It's great. Now another tip that I'd like to share, just a tip, is if you put a mark on the front of your crank pulley, it's a lot easier to see where your pulley is. Because if you're just pointing this down here, you're looking for this tiny mark, and you'll be like, oh man, where the heck is my timing mark? But if you had this line on here, just shine it on the front of the pulley, and you'll be able to see wherever it is, and then just spin the CAS around, and you'll be able to configure it a lot more easy. It's also pretty good having a remote panel. It makes it quite easy. Maybe just hunt for the mark. Looks like I'm actually not too far off. Move it around a little bit. Alright. Now we put the timing lock on. We want to go. And when you come over to our ECU, take it out of timing lock, and that's our timing setup. So this is where I ended up, which in actual fact is not too bad. I'm not too far off. So I'm just going to drill and tap those holes, at least one of them, and yeah, it's getting closer and closer. Alright, so this is going to be fun. Got to make up some mock-up shafts so I can have some shafts made. We're only going to be running NA for now, but see, I've got drive shafts. This is how wreckers remove drive shafts with a red and blue spanner, and got a Honda shafts. And pretty much what I'm going to do is at least this side anyway. This one is the driver's side one, so that goes in the gearbox, and this shaft goes into the axle. Just going to cut it, weld it, and see if I can get something made. If not, then it's going to be pretty drastic measures. I'm sure I can get something made. They're only a certain amount of spline, diameter and stuff. The shafts themselves look pretty similar in diameter. Worst case scenario, I'll be slotting the shafts, joining the shafts, pinning the shafts, sleeving the shafts, all that sort of thing. It should be strong enough, at least for NA. And let's face it, I think it's going to be fun enough NA. So yeah, I just have to see what I can come up with. I'm just going to make it as I go, pretty much. Oh well, here we are. Going to start by cutting the dags off this shaft. It's not really straight, but who really cares at this point? It's just for mock-up and stuff like that. Alright, so we mocked up a caster rod because the assembly is like in the front of the car. Just like join those two shafts like that. Just going to put a spot weld in there, hold them together. You can see I've got daylight in there, so pretty stoked. Drive shafts will work. This was one thing that was going to hinge the build. So I've also got ABS knuckles as well. Not actually sure what knuckles these are, so stuff's getting a bit weird, so I'm going to have to take the pads, see what the pads fit, and then we can figure out what knuckles we've got. We figure out possibly a brake upgrade, and realistically, if we can get ABS front knuckles as well, then we can add traction control if we had a more up-to-date ECU. But that's one shaft. And to top that off, we've also managed to dig up some genuine work CR01 wheels. I'm pretty excited. These look really cool. They're 15x8 and 15x9, 0 offset. Not that it makes much difference to this thing. But with a 9-inch, we can put 275s on this bad boy. Looking forward.